Hello YouTube friends, in today's video I'm going to be showing you another way to prove that when you have sine x, its derivative is equal to cos x. Now to come up with this proof, there are three things you need to know to start off with. That is, the area of a sector is equal to half r squared times x, where x is the angle you're dealing with. The area of a triangle is half BC multiplied by sine A, and because of this isosceles triangle to the left and the diagram, this can translate into half r squared multiplied by sine x, where x is this angle over here that we're dealing with. And the third thing we need to know is that sine 0 is equal to 0 and cos 0 is equal to 1. So with this base, we can come up with our proof, and this diagram over here to the left is also going to be very important. So, with this proof, I'm going to begin by saying that the sector ABC that we find in this diagram over here has an area of half r squared multiplied by x, where x is this angle. What I'm also going to say is that the area of the triangle ABC, which is this isosceles triangle, is equal to half r squared multiplied by sine x, where once again x is this angle over here. Now moving to step 2 over here, it turns out that when x gets small, when this angle over here gets very, very small, the area of the triangle ABC, this isosceles triangle over here, becomes virtually the same as the area of the sector ABC. Okay, so what I'm saying here is that when this angle x gets very, very small, the area of this isosceles triangle, okay, becomes virtually equivalent to the area of the sector ABC. Okay, if we were to zoom in to this circle over here, we'd see that this sector, which is very, very, very thin, okay, would be virtually the same as the isosceles triangle ABC. That sector would be virtually the same. Okay, so you have to imagine zooming into this circle over here, right onto its edge, and you have to imagine a very, very thin triangle, and both the area of this triangle and the area of the sector being equivalent or virtually equivalent to one another. So moving on to 3, in this scenario, the one that I've just described, we can say that half r squared multiplied by sine x is approximately equal to half r squared multiplied by x. And this would mean that sine x would be approximately equal to x. Remember once again that x is this angle over here. Okay? So you need to know number 3 over here and this scenario. If you don't understand it properly just yet, just spend a bit of time looking at it, reading it, and also having a look at this diagram. Now, moving on to number 4, you need to remember that cos x is approximately equal to 1 when values of x are very, very small. Okay? Going to number 5, you also need to know the compound angle formula. You will need to know that sine A plus B is equal to sine A cos B plus cos A sine B. And if you know this, you can move on to finding the derivative of sine x. And you use this formula right over here to get derivatives. Okay, number 6. With the information we have available, we can now write this over here, okay? That is because we've got this formula over here and we are searching for the derivative of sine x. If we use the compound angle formula, which I described up here, okay, what we end up with is this right over here. Okay, so we're close to coming up with our proof. This is the stage that we're at. Now we've got to transform a few things in this expression. What I said before is that when you've got cos angle and this angle is very, very small, what you end up with is getting something that is virtually equivalent to 1. Okay? So, if this change in x over here becomes very small, cos change in x is going to be virtually equivalent to 1. Okay? So this expression over here just changes into sine x. Also, if we have sine angle and the angle becomes very, very, very small, okay, what we're going to end up with is just the value of the angle in radians, okay? So, this sine change in x over here is just going to become change in x, alright? So this expression over here turns into this. And minus sine x over here just remains the same. So what we have is this expression over here. And if we simplify it, for instance, we get rid of this sine x and this sine x over here, and we just have the fraction cos x multiplied by change in x over change in x, alright, what we end up getting is just cos x. So we end up proving with step number 7 that when you have sine x, its derivative is equal to cos x. Okay, so the proof has been complete. It's quite a rare proof. I don't see many people using it. And it can be found in this C3 Edexcel Mathematics textbook over here. If you'd like to purchase this book, you can find a link which will take you to Amazon below this video. If you've enjoyed watching this video, do not forget to subscribe to my YouTube channel. Also, you can find a lot of my work on Instagram, that is on mathematics.proofs. There are many proofs on this page related to GCSEs and A-levels. Anyway, that's all from me for today, and I'll see you around.